Again, welcome back to Precalculus. In these lectures, we're going to learn how to simplify algebraic fractions. And here we need to use the arithmetic fractions rules. For example, addition, subtraction, multiplication, division of fractions. We have to use all the rules apply here also. So our example 1, we have a square b c by ab c square. So since we are dividing, we can change the division sign to multiplication by turning AB by C square upside down or find the reciprocal of it. So this will give us A square B divided by C times C square AB. Then from here, we can cancel. A can go to A square, C can go to C square, B can go to B. So we are going to cancel all the three terms, the denominators. So our final solution will be AC. Now let's look at the second example, which is more interesting. In this example, we may need to factorize some of the expressions. So now we have our first term divided by second term. So the first thing we need to do again, change the division sign to multiplication by turning our second expression here upside down, or find the reciprocal of it. So we get x squared plus 4x plus 4 divided by x minus 1. We turn upside down. Then from here, it's very difficult to cancel. So we may try to factorize. So here, for example, we have 6x squared minus 6. So 6 is common. And we get s squared minus 1. Remember, s squared minus 1 is a difference of 2 squared. So s squared minus 1 squared will give us s minus 1 times s plus 1. So that's the first term. We factorize 6s squared minus 6. That gives us 6s minus 1 times s plus 1. First, 6 is common, so we take the 6 out. Then we have s squared minus 1 squared, which is a difference of 2 squares. And that will give me s minus 1 times s plus 1. Then the down we have s squared plus 3s plus 2. Here we can use our factorization of trinomial. So we look for two values. When we multiply, we get 2. When we add, we get 3. So that would be 2 and 1. 2 times 1 is 2. 2 plus 1 is 3. So we get s plus 2 times s plus 1. Then here we have s squared plus 4s plus 4. Now the same thing, let's look for two numbers. When we multiply, we get 2 and 4. When we add, we get 4. So 2 times 2 is 4. 2 plus 2 is 4. So we get s plus 2, s plus 2. Then here we only have s minus 1, so we can't do anything. Now we can look if we can be able to factorize anything more. So we finish with the factorization of all the terms. Now next step is, let's see if we have to cancel some things. Numerator with the denominator. Yes, s minus 1 will cancel s minus 1. S plus 2 will cancel s plus 2. And s plus 1 will cancel s plus 1. So we can cancel everything at the denominator. So our final answer will be 6s plus 2. Now we can find the least common denominator also as follows. Anytime we have addition between, and so here, for example, to find the least common denominator of a set of a fraction, first we need to completely factor each denominator. So here, for example, they gave us 1 over s squared minus x, and another 1 over s squared minus 1, and then 1 over s squared. We want to find the least common denominator. Let's say, assuming here we have a plus or minus between them, then we have to combine. So the first thing we do is they say we should completely factor each denominator. So we have to factorize the denominators here. So we get x squared minus 1 will give me s plus 1 and s minus 1. S squared will give me xx. S squared minus s will give me x and x minus 1, which is here. So we factorize all the three. Then next, we have to identify the different factors that appear. Now, the different factors that appear here is we have x, we have s minus 1, and we have s plus 1. S minus 1 appear twice. We only need 1. S appear twice, we only need one. So these are the different factors. Then the LCD will be the product of all the different factors. So here we say the LCD is the product of these different factors. With each factor, you use the maximum number of times it occurs in any other denominator. So here we are going to get our LCD then will be x times x minus 1, x plus 1, which will give us s squared, s minus 1, s plus 1. Because the reason why we are using, because again, the different factors from, first of all, the first thing we need to do, we factorize all the terms. So that's what we have, s minus 1, s plus 1, s minus 1, difference of two squares, then s squared is ss. Then we identify the different factors. That we have x, we have s plus 1, we have s minus 1. Then x occurs a maximum of twice in one denominator. And s minus 1 occurs only once. So I have s minus 1 only once. And s plus 1 occurs only once. But we have two s because s occurs maximum of twice. You can see s squared ss. So this will be, we multiply everything, and that will be our, again, least common denominator. This is important. Our previous example, again, we are doing mostly multiplication and division, so we don't need it. So this is a good example now. We have y minus 3 divided by y minus 5 plus y minus 23 divided by y squared minus y minus 20. This is plus or minus, we need to combine. So this means we have to find the LCD. So the first thing, we factorize y squared minus y minus 20. Y minus 5 is already in the lowest term. We can't factorize it no more. So y squared minus y minus 20 will give us, we look for two numbers. When we multiply, we get minus 20. When we combine, we get minus 1. So that will be minus 5 plus 20. Minus 5, minus 5 plus 4. Minus 5 times plus 4 will give me minus 20. Minus 5 plus 4 combined together will give me minus 1. So that's our factorization. Again, y minus 5 is already in the lowest term. So now we find the different factors here will be only y minus 5 and y plus 4. So we multiply them, and that will be our LCD. Because y minus 5 appear only once here, and it also appear only once in the second term. So we have each. So that's why we rewrite it. So we have y minus 5, y plus 4, y minus 5, and y plus y. And we have our terms at the top. So from here, we can combine our terms now, because since the denominator is common, and then we combine the SK here is supposed to be 4. Sorry. There's a typo here, supposed to be 4. Because this is what we have. Now, in order to, if the LCD is this, I have to include y plus 4 at the top. That's why we have y plus 4 at the top here. Y minus 23, we don't have anything because the LCD is the same as y squared minus y minus 20. When you factorize it, you get y minus 5 and y plus 4. So now, since these two are common, we can add the numerators. So we get y squared plus y minus 12 plus y minus 23, combine all. Then possible, we can combine the like terms, and we end up factorizing again to see if we can cancel. So we have y squared plus 2y minus 35. Find two values. When you multiply, you get minus 35. When you combine, you get 2. So that will be negative 5 and positive 7. Negative 5, positive 7 multiply will give me negative 35. When I combine positive 7 and negative 5, I'll get positive 2. So that's why we have this here. Now we can be able to cancel y minus 5, will cancel y minus 5. And it will left with y plus 7 divided by y plus 4. And that will be our final answer. The goal of, again, solving algebraic fractions is to reduce the term, is to reduce it to its lowest term. So next we have another example here, 1 over 3 plus 4 over x divided by 3 minus 1 over xy. So the same concept we can do here, we can combine the two terms here, y by 3 plus 4 over x. Then we combine the down. Then later we solve the problem. So for example, we have x to the power negative 3 plus x squared y to the power negative 3 divided by xy to the power negative 2. So to simplify this, it's up to us. We can change the exponent, which is the best way. We change the exponent to positive. So y to the power negative 3 is the same as writing 1 over s cubed. S squared is positive already, y to the power negative 3. So y, 1 over y to the power 3. Then the down, both to the power negative 2. So we'll bring it down. So next we can find the LCD. We want to do the top first. So the top, the LCD will be s cubed, y cubed. They appear once, we multiply the two. The down is already one term, so we don't need to combine. So after we use the LCD, we get 1 over s cubed plus s squared 1 over y cubed. Then we have to, since we are multiplying this with the numerator, we have to do the same thing with the denominator. Then the next step, we do our cancellations, if combine, and then so our final answer, we get y cubed plus s to the power 5 over xy. So what will happen is that since we are multiplying s cubed, y cubed here, it means we're going to get only y cubed. And here there's y cubed here will cancel, so we get s cubed. S cubed plus s cubed times s squared will give me s fifth. So that's why we have this. Now here we have s cubed, y cubed. So square, it will cancel the 2 and it left only 1. So you get x to the power 1, y to the power 1. So here we say we can simplify algebraic fractions whose denominators contain sums and differences. And that involves square roots by rationalizing their denominators. So the idea here is that if I have this example and they say we should rationalize the denominator, it means we have to remove the radical sign or the square root. So for example, in our first problem, I have a square root of s minus 2. I can multiply it by square root of x plus 2 to make it as a difference of 2 squares. Then we're going to get square root x all square. So the square will cancel the square root. So let's see how they solve the solution. So this is the solution. I have 1 over square root of s minus 2. The goal is to rationalize it. That is to remove the radical or square root sign at the denominator. So the only option is difference of 2 squares. I multiply the numerator and the denominator by square root of s plus 2. Then at the denominator, we have a what? Difference of 2 squares. Square root of x all square will cancel the square root. So our final answer will be square root of x plus 2 divided by x minus 4. Again, the trick is here. I have a square root of s minus 2. So I use square root of s plus 2 to make it difference of 2 square. Because if I square root, the sign will cancel. Square root cancels square. So the same thing if here should be square root of s plus 2, then I'll multiply it by square root of x minus 2 to get difference of 2 squared. The same thing applies to the second one. Here, you can also see that we have a square root of s plus square root of 5. So we multiply it by what? Square root of s minus square root of 5. So we get a difference of 2 squared, square root of s all square, square root of 5 all square. So square root cancel square, then we get s minus 5. Our goal to rationalize an expression means we want to remove the radical sign at the denominator section. The numerator doesn't matter, we just do our normal combining the terms. So So that will be the conclusion of this lectures, how to solve algebraic fractions. Again, to solve an algebraic fractions, we have to use arithmetic fraction rules. For example, how to find the LCD, how to do fraction of multiplication, division, etc. Then since algebraic expressions, sometimes we have to factorize it to reduce. We also have to use the factorization skills here, which I think we covered in our previous lectures. Again, thank you.